When graphing radical functions, it's pretty much the same process, but you want to pay close attention to your domain as well as your x and y intercepts. Now, looking at our first function here, we have f of x equals 1/4 times the fifth root of 6x minus 8. Since this is an odd root, we do have negative and positive x values, so we can fill out our table like normal. I've got these points ready. We've got -3, -0.48, -2.46, -1, -0.42. It's slowly creeping up. We've got 0, -0.38, 1, -0.29. Then we get to 2, that gives us 0.33. And 3 gives us 0.4. And our graph is going to look something like this. All right, let's give ourselves some space and go ahead and analyze all our different components. Okay, since we have this odd root here and looking at our graph, we could tell our domain is going to be -infinity to +infinity. Looking at our range here, now while it's really close to 0, it's not moving anywhere very fast, it still is going up and down very slowly. So our range is still going to be -infinity to +infinity. If you could picture the graph, it would continue going down very slowly, but it would reach all different values for all of these different y values. Alright, so our range is also -infinity to +infinity. Our intercepts, now look, I'm looking at the graph here, I see we've got a y-intercept and an x-intercept. So, since I don't know exactly what those are, I'm going to have to solve algebraically. So for my x-intercept here, for my x, I know I have to plug 0 in for y and then solve. So if I plugged 0 in for my f of x in our original equation, I'd get 0 equals 1/4 fifth root of 6x minus 8. Alright, to solve for that, I'd have to times by 1/4, or sorry, times by 4, times by 4. That's going to cancel my 1/4. That'll give me 0 equals fifth root of 6x minus 8. The opposite of the fifth root is to do the fifth power of both sides. That'll give me 0 equals 6x minus 8. And if I solve for x, I'd add 8, divide by 6, simplify, and I'm going to get my x-intercept at 4/3, 0. Now my y-intercept, I'm going to go ahead and give ourselves some more space to work here. My y-intercept, remember, is where x equals 0. So all I'm going to do is plug x equals 0 into my original function. This will give me, instead of f of x, I'll write y equals 1/4 times the fifth root of 6 times 0 minus 8 instead of x. That's going to simplify to y equals 1/4 fifth root of -8 here. I can plug that fifth root of -8 into my calculator, times that by 1/4, and my y-intercept is going to be 0, about -0.38. Looking at my end behavior, as I move to the left, it is getting close. It does look close to 0, but it is slowly moving down and down and down. So my end behavior on the left is going to be -infinity. Very similar to the right, it's slowly going up and up and up. That's going to be going to +infinity. We can see our function is continuous all the way through, so it's continuous from -infinity to +infinity. And if we move from left to right, it is very slowly increasing the whole way. So we are increasing from -infinity to +infinity, and we are not decreasing anywhere on the graph. Alright, let's do one more example. Here we have f of x equals 3 times the square root of 6 plus 3x. Now this time, our root here, now we don't see anything here, but remember it's automatically a square root. This square root it has an even root. So we do have a restriction on the domain. So before I even make my table here, I'm going to find out what my domain is, what x values are relevant. And remember, whatever's in this square root has to be positive. So I can set up 6 plus 3x is greater than or equal to 0. So if I subtract 6 and divide by 3, I'm going to get x is greater than or equal to negative 2. And this negative 2 is where I'm going to start my x values at to pick points, because I know anything less than that is going to be not included in the graph. So I'll go ahead and choose negative 2, negative 1, 0, 1, 2, 3, and 4. Why not? I went ahead and plotted our points and graphed our function. Now let's talk about the domain, range, etc., etc. So looking at our domain, our x values start at negative 2 all the way to infinity, which is what we solved for before, so that makes sense. We've got negative 2, I'll do a bracket to include it, negative 2 to infinity. Our range, our first y value starts at 0 all the way to positive infinity. So I will include 0 with my bracket all the way to positive infinity. My intercepts, it looks like I've got an intercept right here and right here. So our x-intercept, I've already solved for this, so I don't need to. This is negative 2, 0. Negative 2, 0. Our y-intercept, that's right up here. I've also already solved for our y-intercept. That's where x equals 0. I have 0 and 7.3. So our y-intercept is 0 and 7.3. Next, let's look at our end behavior. We've got no end behavior for the left. We'll cross that off. Our right end behavior is going all the way up, 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 up to positive infinity. Our continuity, we don't have any function over here left of negative 2, but once we get to negative 2 moving to the right, it is continuous. So we are continuous from negative 2 until infinity. Looking at increasing and decreasing, we are an increasing function. We're only moving upward, but again, it's starting at negative 2. So we are increasing from negative 2 all the way to infinity, and the function does not decrease at all.